40.
Okay, it's time. We can get started. Some of you might already have wondered if you should finally start that passion project to build open hardware computers by hand. Well, in any case, after this talk, you will be already one step ahead, one step further into understanding how to get started, what to do, what not to do, and which challenges you might want to mentally prepare for beforehand. It's gonna get quite technical today, so I will leave the word to an expert now. Please give a warm welcome to Lukas Hartmann, proud founder of the MNT Research Company in Berlin.
All right. Hi. It works. I am Minit, director of MNT Research. Thanks for having me today. Originally, I structured this talk differently. I wanted to give a systematic walkthrough of making a mobile computer and all the subsystems, but I realized it was going to be a bit boring and I didn't have the time to give each topic the space that it needs, but each of these topics is quite complicated once you get into it. So I guess that walkthrough would be better as a series of articles or videos. It's just too big for one 30-minute talk. So I was thinking what I could talk about instead, that only I can talk about, what topics make sense for you to get kind of my unique perspective on. So I will sketch out the history of what my team and I have been doing in the last 7 years and visit some interesting or problematic points in that history where you can maybe learn from our mistakes and successes. And hopefully it will inspire you to do something similar or contribute. The original reform project started in 2017 when I was at a crossroads after being frustrated with Apple, after being frustrated with Microsoft before that. I had a Retina MacBook Pro from 2013, and after the happy times of Snow Leopard, it was getting obsoleted by Apple. Slowly, software updates could not be installed anymore. You were forced to upgrade the OS, and then the computer would suddenly be slower than before. So I installed Linux on that MacBook. There was a boot manager called Refinement, and it allowed to dual boot OS X and Linux, in my case Debian. Incredibly, the MacBook was suddenly totally snappy under Linux, and I could install and tinker with any software that I wanted. But there were many problems with drivers, especially Wi-Fi just didn't work right, and I had to use USB dongles and such, which was annoying, especially because I realized that Apple didn't provide in-depth hardware documentation that would have allowed me to learn more about how that machine worked. From my childhood, I was used to computers that were much more transparent in that sense. In the early 90s, I got handed down some older computers from other family members or classified ads like the ZX81, ZX Spectrum, Commodore 64, and Amigas. Back then, it was normal that there were handbooks or third-party books that had detailed schematics and tables of the whole memory space of the system. And I even had some huge book by Data Becker that had the whole C64 ROM disassembly with comments. It was also a time where the maker movement was in some kind of hype cycle, and there was a boom of distributed additive manufacturing, like 3D printing. There was a huge fab lab in Berlin, which, with all kinds of machines, now long closed, and it became possible to order custom PCBs cheaply and quickly from some Chinese services like Dirty PCBs and PCBWay. Also, very importantly, KiCad, the open source electronics design program that I'm using all the time, was starting to get usable. All these things coinciding, the hubris was strong in me, and I asked myself, how hard could it be to just DIY my next laptop in such a way that would bring back that cozy computer feeling from my childhood? But even better now, because now we have this open source culture and the internet, so other people can collaborate on improving that machine as well. Through Greta and Fab Lab, I met Anna Dantas, a young industrial designer. I asked her if she would be interested in doing the industrial design for this new laptop, and she said yes. Today she is still working with us on every computer we release. So the advice, teaming up with another skilled person who is really determined to get things done is highly recommended. My biggest learning at that time was that getting things done and then improving them again and again works better than endless debating or perfectionism and never shipping anything. This is of course easier if you don't really know what you're doing, because you don't know that certain things are unlikely to work and you'll try them anyway. And you might get lucky or discover some unorthodox new way of doing things, which is valuable. Also, Greta grew into the important role of doing detailed reviews and criticisms of the almost final case designs and making sure that we really polished them in the last rounds before a production run. We started with a very primitive way of designing the system, picking a processor and a development board for it that was open and documented as possible, and then choosing the other required parts so they could fit in a roughly laptop-shaped box and wire everything together by hand. At this stage, there was no custom PCB involved, except for the keyboard. Nowadays, most DIY computers in this category would be called cyberdecks. The box with IMX6 development board, HDMI display, some hobby RC car battery, and custom keyboard was mega clunky, but it worked and made it seem more possible to achieve the real goal. Nowadays, I still follow this approach. You can try to imagine a lot from reading the specs, but nothing beats getting the development kit for a new chip and wiring it up to a display and installing a system and getting a feeling for can this work at all. We refined the box into something more laptop-shaped, and I started to work on a custom motherboard in KiCad. The IMX6 dev kit I was using before, it was actually two boards, a carrier with all input-output ports, and a tiny stamp that had mostly only the processor and the memory itself on it. It's like in the middle of this photo if you squint. This is called a system on module, and it saves you the hard work of wiring up the memory chip and the most critical power supplies for the processor. Also, more importantly, it frees you from dealing with the processor manufacturer directly. Instead, you buy the module from the module manufacturer who has to stock the processor and is willing to sell you in smaller quantities. Most chip companies are not really interested in selling you just one or even 100 processors. Or they have really long lead times, like a year after you order. A downside is that the modules themselves are almost never open hardware, which means you can't just clone them. But if you're pragmatic, they can be seen as a standard part that is available from several sources, and the rest of your system can still be open hardware, which is better than a totally closed system. I will get back to this point later. Anyway, we made the first thing that looked at least like a retro laptop, and that was mostly made from custom designed parts. All the mechanical stuff was 3D printed or laser cut. Even the keycaps were 3D printed. It was a huge and glorious mess. So to check if anyone else was interested in this sort of computer, we offered around 10 of these very early versions of Reform to adventurous people on our website for I think €600 each. And to our amazement, they sold out pretty quickly. The demand was validated. Back then, all the PCBs were hand-assembled with a stencil and solder paste on the kitchen table at home by Greta. This is actually the right slide here. And reflowed using a very bare-bones hot plate thing called reflower. We were torn about the manufacturing of the case parts. We really wanted to have a method that could be reproduced by anyone, but weren't satisfied with the slowness and imprecision that 3D printing had back then. Anna set up a temporary lab at the University of the Arts in Berlin for, I think, several months to try if she could vacuum cast the parts, but although promising, the results were unsatisfying, with lots of bubbles or broken corners. So that was the point where I decided to try aluminum CNC milling and actually outsource that part to a relatively small company in China, JPR. We still work with them today on all the laptop cases. A similar thing happened with the keycaps. We tried so many DIY things, and they were just not good enough to make sense for an enjoyable laptop. So we partnered with a small team of people who are obsessed with keycap molding, FK caps. We managed to coordinate a group buy with them of several keycap manufacturers, where the keyboard manufacturers, where the keycaps would be injection molded from translucent ABS and then painted with a black PU coat. We can then selectively remove parts of the coat with our laser engraver to label the caps in a durable way. That also works well with backlighting through the cap. This is a point where we had to decide that additive manufacturing would not bring the required quality for critical parts that you touch all the time, like the case and the keycaps. Still, our design files are open, and you can 3D print these parts or clone them in any of the many places that offer CNC milling or industrial SLA printing. And I'm sure additive methods will still get a lot better in the next 10 years, so we can even be more independent from big factories. For Reform 1, we still ship the DIY printed caps, but there were many issues we encountered in real-world tests with the laptop that we decided to completely redesign the laptop and also upgrade the processor to IMX8M. Although it was binary blob-free and had awesome documentation, including the memory map, the 32-bit IMX6 seemed too slow for a daily driver, and I made the difficult decision to switch to the new processor, the 64-bit IMX8M, which introduced a binary blob, so a closed-source piece of firmware, for its memory controller. I designed a new motherboard for the Reform 2, based around the IMX8M module from Boundary Devices, which Greta kind of found at the last minute. We chose it because, unlike all the others, they had publicly downloadable PDF schematics. The Reform 2 was the first computer that we sold and shipped in a bit more serious quantities. This was possible because we did a crowdfunding on CrowdSupply. The redesign had some radical elements, like using 8 user-exchangeable battery cells in a standard size, 18650, and using the then still pretty unusual lithium iron phosphate 4 chemistry. Also, all the cells are wired in series, so the system operates at up to 30 volts internally. Around that time, Timon Skeruch introduced me to Alan and Zoe of Fully Automated, who were really into battery power system design, and they taught me a lot of stuff. I also got introduced to F. Schneider from FixMe, who had a lot of electronics and keycard knowledge and helped me debug tons of things. I also want to thank Josh here at this point for totally cleaning up our act in terms of solid Debian Linux integration. So all of this was not, possible because I read tutorials and YouTube videos, but also because I got lots of help from really nice people. The blessed, cursed module. There was a time when the binary blob topic was really nagging me. Also, the Free Software Foundation was nagging us. Because some people on the internet were pretty obsessed with this topic. My red line was pretty much like, I don't want to run closed-source binary software on my main CPU. If a peripheral like the memory training needs some closed code to run at boot, then that is very unfortunate, but we'll have to live with that for now. There was, though, one Cortex-A72-based processor with graphics integrated that did not need a binary blob to train the memory, which was the NXP Layerscape LS1028A. So you can boot Linux on this processor without any proprietary bits. But to get display output, it needs some binary firmware in the DisplayPort controller. I had the idea that for purists, we could work around this with some PCI Express-based add-on, but I didn't get around to that. Back then on Twitter, I got to know the electronics company RBZ from Madrid, who were eager to collaborate with us on a from-scratch open hardware module based around this chip and 16 gigs of memory. The work was funded in part by an NLNet grant. It was extremely hard to get this module to work and ultimately shipped. there were so many issues on the way where I wanted to give up that we ended up calling it the cursed module. For example, when we were finally ready producing the first batch of the boards, the processors were completely gone from the market. And lead time was almost a year. Only with luck and a contact at NXP, we were able to get a shipment of strategic samples that were not listed in anywhere. Then the boards did not boot most of the time. Nobody, including NXP, knew why. I then found out weeks later it was because of a floating JTAG reset pin that I had to hand fix by soldering on all the production modules. In the end, we sold and shipped maybe around 50 of these modules. I'm not sure if its existence has helped us or not. I'm happy that I didn't give up, and I'm grateful to everybody who made it happen, including RBZ and Elnet. We certainly learned some lessons here, mainly that it is extremely risky to try such a design if you have a shoestring budget. But it is certainly possible if you have a very high pain tolerance. Around the same time, I wanted something really pure at the heart of reform, so I designed an FPGA-based module, the Kintex 7-based RKX7. It was also a time when there was a lot of activity in the open FPGA toolchain space around Yosys and Litex and so on. I wanted to be able to say, here's a system where the SoC is open source at the gate level design. You can let it have RISC-V cores or microwatt PowerPC cores or Motorola 68000 cores if you want. And it all worked out. While glorious, unfortunately, these two purity projects cost us dearly in terms of time and energy, and only a few people really benefited from them. Meanwhile, the company couldn't sustain itself from online shop sales between crowdfundings, even if we tried very hard. We had to reinvent our stuff to be more useful for more people. The lesson here is, pick your battles. These were, in a sense, ivory tower projects. Philosophical purity will be appreciated by only very few people, even if these people tend to be quite vocal on the internet. I am thankful that there are critical people who are fighting to make sure every last bit is open source. But in the end, most computer users are pragmatic and are willing to make small trade-offs if it means they can have a more comfortable time. So that's why I say 90% is better than 0%. If you have a lot of money and the resources, by all means go and try to make the 100% perfect system. To quote Nine Inch Nails, I tried and I gave up. Now I firmly embrace that 90% is better than 0%, and things can be slowly improved over time. But let's get to more fun topics. The main issues with the processors we had up to this point was that even if you could play Quake 3, there were performance problems with heavy JavaScript websites like YouTube, and people were relying more and more on web platform-based applications. After making around 500 laptops, it became clear that we needed something that didn't have issues playing YouTube to justify charging 1,000 euro for a laptop. When I got my first COVID vaccination, I was pretty feverish, and I drew up a thing in KiCad at home that felt more like a joke at first, but in the end, it was really important to us, which was the RCM4 module. The idea was that to make an adapter for the pretty popular Raspberry Pi CM4 module, so you could use that as your processor in Reform. In the end, almost nobody did that, but instead there was an even faster but almost pin-compatible alternative module, the Banana Pi with Amlogic A311D processor. It turned out that the company Bay Libre had spent a lot of work on getting Amlogic processors to work well in mainline Linux. The A311D also has a Mali GPU, and I could finally try out the Panfrost open source GPU drivers that I heard a lot about on the Mesa mailing list. Neil Armstrong, who maintained a lot of A311D stuff in the kernel, was very approachable on IRC, and this pretty low cost but much faster module really breathed new life into reforms everywhere. I'm not sure what's the lesson here. Maybe that you should follow your fever dreams more often than not. Sometimes your subconscious knows a better strategy than you do. I would maybe call this the David Lynch way of hardware development. Yeah, pocket reform, the cutest reform. I'm not 100% sure how pocket reform became a serious project, but we ended up in a meeting with Anna and her then engineering design colleagues Pooja and Katarina in search for a new collaborative project that their team could do user research for in a one-year government stipend. I remembered that I had an obsession with ultra-mobile PCs and PDAs like Xeon Series 5, Nokia Communicator, and Sony Vaio P. And I also wanted to do something that could start us on the road to replacing a smartphone for some use cases like writing. So it had to get a slot for a cellular modem and basic telephony support. As far as I know, nobody except me ever made a real phone call with the device. So we ended up figuring out what could be the smallest viable mechanical keyboard on a portable device. And Anna's team made a lot of lo-fi prototypes and showed them to lots of people. I gave NXP one more chance and decided to go with IMX8 and Plus that allowed us to use 8 GB of RAM and overclock to 2 GHz. Okay, I'm running a bit out of time, so I'll skip a few things about this. In production, we encountered several nasty obstacles. The biggest problem was that the display, while quite brilliant and well-known from Nexus 7 version 2 tablet, was end of life, and I didn't realize that most of the existing stock has quality issues. So we couldn't get this display fresh from the factory, and whenever we ordered batches from several suppliers, we had to QA test them and throw a lot of the displays out. We found a company that, after already paying for 500 displays, told us that they can't actually supply them in a usable quality. But they offered an alternative solution, kind of half-cooked up by themselves, that would use fresh panels with almost exactly the same form factor, but incompatible on a driver level, and which needed a different way to control the backlight. We came up with solutions for all of this, but it took more than a year, also because they were often unresponsive or delayed things for months. I spent many days grinding and trying to get their new display to work, and when I once more wanted to give up, got it working in the end. Then they raised the price, so we could only get 350 instead of 500 for the price we had already paid. Then, when we finally had the displays, we realized it was very slightly thicker than the old one, and our front bezel would squeeze it and cause backlight leak. After much hair pulling, we came up with a 0.3 millimeter thick frame, laser cut from Mylar, that we can use as a gasket. The Pocket went on to be much more successful and beloved than I ever thought, so it totally saved us. Here's Henri signing his key visual artwork for the Pocket Reform. Here's Greta representing at the last Chaos Camp. Here's Liaison testing Pocket Reforms before shipping. And here are Tina, the dog, and Henri watching over the production. Okay, I need to hurry up. Yeah. In the meantime, Chinese chip company Rockchip had finally made a really decent ARM SoC that was surprisingly fast, including a good GPU, and the ability to address lots of RAM. It has 8 cores, 4 of them A76, and made on an 8 nanometer processor, so it doesn't use too much energy and can be passive cooled. I decided to start an adapter for the T-Firefly module with this processor once it became clear that a team around the open source company Collabora was heavily investing work in mainlining the drivers for this chip, and especially its GPU, which was the Panther and now PanVK for Vulkan support project. The adapter for this module was challenging to develop because it has so many pins and features, and I wasn't yet familiar with Rockchip's style. But I was able to convert and extract part of Firefly's Altium schematics and footprint in KiCad, thanks to KiCad's Altium import feature. When the first PCB of the adapter arrived, I was mega anxious if everything would fit mechanically, and it did. And the processor booted. We shipped the first batch of this module a few months ago as an upgrade for both Reform and Pocket Reform. And it's quite satisfying for me that our laptops are now more performant and usable than the 2013 MacBook that started this story. Yeah, Reform Next. This is the last one. In the beginning of 2023, I kicked off the Reform Next project with the goal of redesigning our 13-inch laptop, this one, to be more compatible with more people's expectations of a laptop. I also was a bit tired of reading the comments on tech websites about how thick and clunky some people found our laptop, and I wanted to stick it to them. The idea for the Next was to do something pretty impossible, to make it around 25 millimeter thick instead of 45 millimeter, while still keeping the 8 batteries and the mechanical keyboard, something that no other laptop would be able to pull off. To achieve this, I sacrificed the acrylic bottom plate and the trackball and split up the motherboard into a lot of smaller PCBs that are spread out all over the main body of the laptop. The motherboard is now much smaller and fits upside down on the trackpad and between the 2 battery packs. The processor is cooled by conducting heat directly to the massive aluminum bathtub design of the main body. I also remembered the Novena laptop, one of the inspirations for Reform, and so we put a 40 millimeter spaced mounting grid under the keyboard where you can mount your own electronics. The ports are completely separated from the motherboard, which was something inspired by Timon's damn Linux tablet design. This also means that anyone can design alternative port sections for the laptop, as they're just PCBs, like this, that don't need any special housing except for a port cover, which can also be made from PCB material. Yeah, just for your information, we also launched the crowdfunding campaign for this laptop yesterday. Yeah, and this is Jacqueline's Reform. I always have to show it. So Jacqueline is someone from Australia who cloned the Reform and modified it heavily from our files. So it's actually possible to copy our stuff, which was the whole point. I hope there was something for you in this story. And I'm here with some of my teammates at the MNT Research Assembly in Chaos Zone, where we're happy to discuss anything related to open hardware. Thank you.
Thank you so much. I think we can all agree that they did a great job. We still have a few minutes if we have some questions in the audience. If you have some, please raise your hand. I will give you the mic.
Hi, first of all, amazing project. Do you have an estimate on what the new generation that you're crowdfunding now is going to cost?
Not even an estimation. So it's like all the prices are already there. So the entry-level model is $1,099.
Any other questions? Yes.
Hey, thanks for the talk. Do you have a shut up and take my money option now?
Yes.
Nice.
It's like there on this link. I didn't want to like to do too much marketing stuff here though.
Anybody else? Yes.
Hello. How do you find which main processors to choose?
Yeah, so, I mean, it was kind of in my talk. So, we started with something that was the most documented, the most kind of open-seeming, the least binary blob encumbered stuff. And that was from NXP usually. Like they have a, like before they were called Freescale, and they had like a really good track record of actually documenting their processors. And like, which kind of got lost in the last years. And maybe there's TI who still do something like that. But most companies don't want to give you a lot of details anymore unless you sign NDA. And yeah, everything is kind of secret and locked down. So it's getting harder and harder. So the approach is kind of like, okay, we offer like a range of modules to choose from. So you can make the choice. What's important to you? Like, should it be like 90% open but very fast? Because I need to watch YouTube. Or do I mainly want to do text, work on text, for example, writing and so on? And then I can use the more open option that is weaker in terms of performance. But yeah, it can't play Cyberpunk 2077.
Okay, we've got a question in the back.
Yeah, hi. So again, thank you for the great work. My question is about Raspberry Pi and now with Pi 5 and all. So how do you see that growing? And especially there's software support, Raspberry Pi desktop, Raspberry Pi Connect. It has a very nice ecosystem, and people will already get a lot of things ported and working, right? So do you see MNT reform also moving in that direction, or like supporting more of Raspberry Pi 5, CM5 type devices?
Yeah. So I don't want to kind of comment on the MO of Raspberry Pi, but so we already support the CM4, and the CM5 is kind of pin compatible. So it would need only like a few changes to the adapter to make it work. So far it hasn't been done, but it's also not out yet for a long time. But it's definitely totally like possible, and it would be cool to see that. Yeah. The rock chip is a bit faster though.
Okay, thank you. We've got another question here.
What do you think? To what degree? Oh, over here. To what degree do you think people are drawn to the MNT laptops because of the somewhat unusual peripherals like mechanical keyboard, trackball, the whole more, I don't know, the different design style as opposed to openness, if you can tell at all?
Yeah. So I'm not sure if I 100% get the question, but it's about what people are drawn to, right?
Yeah.
Which aspects they are drawn to?
Yeah. Are there? Do you think are there people who do not care that much about the openness, but more about the other aspects?
Yes, there are also such people, for example, who are asking like, couldn't you put AMD, Intel module in there? Why not, right? Because then we still have the rest, and nice mechanical keyboard and the customizability and so on. That's totally fair. But yeah, there's a thing. So I think like the people come from very different. Like everybody sees, or there are different groups that like different aspects of the thing. And I don't want to betray the whole openness idea, right? So, but I think we can do this and that for different people. So, yeah, for example, there's this thing called Latte Panda, which is like a very small, I think, Intel N100 module that people could integrate.
Okay, we've still got 5 minutes.
Just as a clarification, so I didn't mean to say you should do this or that. It's more about whether you could tell to
I
how
got it like
large
that.
like the portions are.
Yeah, I don't really know. Yeah. But yeah, I think the most important thing is that we kind of show that you can interact with us, and you can actually contribute. It's not so hard to get. There's not a big barrier between us and everybody who owns the thing. So yeah, so we are not a faceless corporation who says like no, stay out of this. But we kind of invite everybody to just be part.
Okay, next one.
First and foremost, thank you for a great talk. I'm going to ask you: are you more focused on developing open hardware and like making this work, or do you also care about making the different Linux OSs to be possible to be run on this hardware, like without actually for a newcomers, without actually digging into the device tree and like all those embedded stuff that is important that you need to do. What's your stand on that?
So I think it is going to change now a bit because so we try to focus on one operating system just because we didn't want to spread ourselves too thin. So that was Debian. which also like stuff like Ubuntu is based on. So we were like, okay, this work can also be used by others and so on. And they have third parties who brought up like Arch Linux and Void and so on, and also BSD people, and we got a lot of 9-front people who ported like Plan 9 to the IMX. And now it's kind of, it will be easier because now there's EDK2 support, which is kind of like UEFI BIOS kind of thing. So you can have a graphical interface, text mode interface, and then that has kind of a standard way of booting other stuff.
Great.
For the first time. So it's kind of similar to a PC platform where you expect that to just work. Yeah.
Okay.
Okay, do you need to
one more, please. One more, please. Do you have something to sell? Some PC platform that you made to sell on this congress with you?
No.
Okay.
We don't sell the computers here.
Okay.
Only merch.
Thank you very much.
We've got one question from the online audience.
Yes, the internet would like to know if you expect there to be a module with RISC-V chipset.
So theoretically, so there is already someone who did that. It's almost like it doesn't have display working yet or so, but there's like the Mars 5 CM4 type module that works with our RCM4 adapter. So there is one. So if you're interested in that, just give that person a hand in the forum. So it might work in a few days. But in general, I've been watching RISC-V a lot, and there still hasn't been like a chip where I would say, okay, it's worth the energy to make it work, because it's not yet, like in terms of performance, it would be like a step back still. But I think it's going to change in the next few years. So it will be more interesting.
I have a question about CE compliance. Yeah. So what's your take on that? Did you mention it already? What's your how much effort, how much cost does it generate? Yes.
Hard question. So it can be very expensive to do CE testing. There are some companies, local companies, who can do it. There was in Berlin some options that allowed us to kind of through contacts get a better price. You know, someone working at the company who would make us a better deal to go into the chamber. And there's also Chinese companies who can do it. Like if you can't afford to spend 10,000, 20,000 on it, you can get it for maybe 2,000, 3,000, 4,000. But it's only relevant once you kind of start selling hardware, not for like hobby projects. Yeah.
Okay. Time is up. Let's wrap up this session. Thanks you all for listening, and thank you for the brain cells. A last round of applause for our speaker.